Okay, this is getting hard. So I've got a cosecant squared, but I've also got this inside of the trig function. So I'm going to suggest we let u equal 1 plus x to the 4th. Then du is 4x cubed dx. So if I just rewrite this so that I've got the trig function first, and then this x cubed dx over here, then I can see we're going to have integral of cosecant squared of u, and then this right here is right there, 1/4 du is x cubed dx. So 1/4 du. So if I pull the 1/4 out, and you're thinking, I know the antiderivative. That's a negative cotangent of u plus a c, negative 1/4 cotangent of 1 plus x to the 4th plus a c. Sorry, that's really messy. Negative 1/4 cotangent of 1 plus x to the 4th plus c. All right, let's try this other one. So if I let u equal the inside function again, so that would be the angle, 1 plus x to the 3/2, then I take the derivative, 3/2 x to the 1/2, and you're starting to get the idea, I think. So I know I could rewrite that, move things around, or if you don't need to rewrite it, I just make sure that you can see where all the pieces are, right? So just color coded here. Okay. So you know I can put this inside here, right? So I get sine of u. And then using other colors, I need to find x, or root x dx. Oh, there it is right there. So if I could say 2/3 du is root x dx. So I don't have to have them written beside each other. I just know I'm putting in a 2/3 du. And again, the only thing that carries is the integral sign. So I can take the 2/3 outside, and I know the integral of sine is negative cosine plus c, negative 2/3, and cosine of the angle plus c. What's happening here? Let's let u equal tangent, the inside of the e function. So du is secant squared x dx. Oh, that's not looking so good, is it? E to the tangent times 1/cosine squared x dx. Always thinking, right? So I see I can get e to the u, but how am I going to get rid of that cosine squared? Oh, wait a minute. Cannot this be written as, isn't 1/cosine squared secant squared? Oh my goodness, it is. So this gives you e to the u, and then secant squared x, that's a du. I'll just keep going up here. Integral of e to the u is e to the u plus c, and then you put the u back in. So that's e to the tangent of x plus a c. Okay, you know that this cube here means that this whole trig function is cubed. All right, so I'm going to let u equal sine of theta, and then du will be cosine of theta, d theta. Okay, so I get u cubed. Look at that, du. And so that gives me 1/4 u to the 4th, and then I put the x's back in, or the thetas back in, I should say, to the 4th plus c. All right, again, the denominator can be a good choice. So if I let u equal cosine of x, the derivative is negative sine of x dx. I'm going to reorganize this one. So sine of x dx. So this gives me 1/u, and then I'm going to be multiplying through by a negative sign to get the sine of x, right? So that's negative du. So negative integral of 1/u is ln of u plus c ln of u, which is cosine of x. So this will be something you'll be memorizing in the future. Isn't sine over cosine tangent? Oh, it is. So this will be on your list of things to memorize in a while. Not until the next test, at least. So you're okay to just do the substitution. So test 4, not test 3, test 4. Okay, so let's look at this one. It's going to be similar. We'll be deriving something that you'll want to memorize. Okay, I'm going to say let u equal the denominator again. Du is cosine. So if I take this, it gives me 1 over u du. Well, that's just ln of u. And so then I've got to put the u back in, ln of sine of x plus c. So what's this one? This is the integral of cotangent. So the integral of cotangent is ln of sine. All right, last few here. So I'm going to let u equal this e to the x. So the 1 e to the x, that's inside both trig functions. And then du is e to the x dx. So this here turns into secant of u, tangent of u. And then this e to the x dx gets replaced with du. So what's the integral of secant tangent? Secant plus c, and then I put the x's back in, plus c. Okay, let me stop